Good morning. Thank you all for being here. Thank you to Yuan for the introduction. I'm excited to talk about some recent work we've done called skill squatting attacks on Amazon Alexa, or in other words, a talk about Internet of Things security and machine learning. So if you want to leave, feel free to. This work is done with a group of great collaborators from the University of Illinois. But let's get into it. Internet of Things devices are here, hooray! A great example of IoT in the real world, smart speakers, Amazon Echoes, Google Homes, and these speakers have kind of dominated this space. Some studies report that by the end of 2018, 50 million American adults will have a smart speaker in their homes. That's great. But these devices are interesting because they kind of forego traditional computing inputs like keyboards or mice or touch. Instead, they use the human voice as their primary input mechanism. Unfortunately, speech recognition systems that underlie these devices frequently make errors and get things wrong even when you're using them normally. I'm sure we've all experienced this. I'm seeing some head nods. But let me share a personal story. So last week, I'm sitting in my living room. The lights are going, the sun's going down, lights are dark. So I'm like, oh, okay. I have an Echo and I have smart lights, so that's great. So I'll just say, Alexa, turn on the living room lights. Fairly simple task. Does she turn on the living room lights? No. She says, with the confidence that really only a computer can have, she says, okay, playing Living on a Prayer, Lullaby Edition. It's not quite what I asked for, but I will say it is surprisingly true to the original. But Amazon is not content with having your smart speaker or your Echo turn your lights on and off in your home. Amazon wants to use Alexa to take over the world. And in order to do that, they've built a platform that enables third-party developers to interface with Alexa directly. These are called skills. So at the time that we wrote the paper, there were about 25,000 skills on the Alexa skills store, and this number was growing rapidly day by day. But there's a skill for everything. There's a skill, you want some facts about cats? There's a skill for that. You want to call a Lyft to go to the airport? There's a skill for that too. You may need to make like a highly sensitive, time-sensitive bank transfer, and you only want to use your voice. Yeah, there's a skill for that too. That's great. So the way to think about skills is that they're apps, but for Alexa. But they're different in one very important way. So unlike a mobile application, when a user has to go to an app store, download the application, and click on some stuff in order for them to use it, all Alexa skills are enableable by default. So basically, you can just say something to your Echo, and Alexa, if it determines that you want to talk to a skill, is going to try to make a determination about what skill you wanted to talk to based solely on your input. So let me give you an example. Let's say I'm in the mood for some cat facts. So I say, Alexa, tell me some cat facts. So Alexa says, oh, that sounds like a skill. Let me figure out what skill to send this particular request to. Let's say in the universe of all skills, there are 3 that kind of sound like cat facts. There's cat forks, which is not right. There's cat fast, which is also not right. And then there's cat facts, the skill that I wanted and the skill that Alexa chooses. So what she does is she routes my request over to that particular skill, solicits a response, and then says something to me like, did you know a group of cats is called a clouder? It's a very interesting fact about cats. So we now have 2 fundamental pieces of intuition. The first is that Alexa makes mistakes because speech recognition technology is not yet totally mature. And 2, skills are the new apps. And based on what you say to your Echo device, Alexa is going to try to make a determination about what app you want it to talk to. What could go wrong? So look at this skill, Fish Geek. It's a simple skill. It does a very simple thing. You can just ask it stuff about fish. Okay, look at this skill, Fish Geek. Everyone in the room, I know, I've read the audience, they're all security people. So everyone went to the same place and said, oh, it's a phishing attack. Oh, it makes sense. Well, kind of. Have you heard of these guys? They're an American rock band from the 1980s called Phish. And it turns out that the skill that I just showed you was a skill that was intended to provide information about Phish the band, not like Fish the fish. So, but the question here is, okay, if I were to say, Alexa, tell me a fish fact, and both of these skills were triggerable, how would Alexa know which one I wanted? Well, it turns out, she actually kind of doesn't. Rachel, a disappointed Amazon customer, left a 1-star review of the app Fish Geek. Her complaint, it gave her fish facts, not fish facts. And this kind of foundation, underlies the core research question in this work, which is, can Alexa errors be leveraged to cause harm to end users? And to that end, we introduced this new attack called a skill squatting attack. The core idea is fairly straightforward. If an attacker knows a priori what predictable errors or what errors Alexa is going to make when routing somebody to a particular skill, then all an attacker has to do is build a skill that sounds like an intended skill. So when a user triggers their intended skill, they're instead routed to the attacker-controlled skill. So let me walk through a very concrete example. So we're in the same scenario as before. I want some cat facts, really need my cat facts fixed. So I say, Alexa, tell me some cat facts. And now the only difference from the prior example is that the attacker knows that facts, F-A-C-T-S, sounds a lot like the word fax, F-A-X. And the attacker also knows that Alexa prefers the word fax, like the fax machine, to the word fax, like fax about something. So when I make this request, Alexa doesn't choose the skill that I wanted. Alexa is going to choose cat fax instead. And then everything happens as before. You know, my response gets sent over to the skill, she gets a response, and then she tells me something stupid, like a group of cats is called a murder. So, you know, kind of intrinsic in this example is, okay, well, how can you tell which errors are predictable? So how do you know? Or how's an attacker going to know? Well, we are primarily a measurement group, and so what we did is we sent a bunch of speech samples to Alexa, and we figured out where she goes wrong. So in order to kind of investigate this a little bit deeper and investigate these predictable errors, we leveraged this data set called the NSP data set. So the NSP data set is a linguistic data set. It's curated by a group of linguists at the Ohio State University, and it was built to study different English dialects across the United States. So the NSP data set contains lots of different kinds of speech samples, but the ones that we focused on in particular for this study were single-word speech samples. So there are 188 words in the data set, each spoken by 60 different speakers, which makes for a total of 11,460 audio samples. And I want to note the speakers were also distributed geographically. They were selected especially because they demonstrated representative linguistic features of different dialect regions. So in the United States, these are the West, North, Midland, South, Mid-Atlantic, and New England regions. So we took all these speech samples and we sent each speech sample to Alexa 50 times, providing us with a total of 573,000 transcriptions across the 60 speakers. So what did we find? Well, of the 188 words, 24 of them we denoted as had a predictable error. So these are words, let me explain, that kind of fit two criteria. First is that when they're spoken or when they're transcribed by Alexa, they're often interpreted incorrectly. And two, when they're interpreted incorrectly, they're interpreted consistently in the same way incorrectly. So for example, the word sail, like a sailboat, is interpreted as sail, like we're having a fire sale. In the paper, we delve into these a little more and provide some explanations. But I want to note that it's not just homophones, right? Even a human would have a hard time distinguishing between sail and sail because they sound exactly the same. But what's more interesting is that there are some categories of words that fundamentally sound different. They have underlying phonetic structure that is different. Rip and rap, wet and what, luck and lock. And in the paper, we talk a little bit more about these and kind of provide some explanations, but for the scope of this talk, it's enough to know, okay, Alexa makes some mistakes, some predictable mistakes. The next question, can we actually use these predictable errors to route users to unintended skills? In other words, we want to know if these predictable errors actually manifest themselves when Alexa makes a decision about which skill to route a user to. So what we did is we split our speakers in half into two sets, a quote-unquote training set and a quote-unquote testing set. And what we did is we identified all of the predictable errors that were from the training set. And given those predictable errors, we then built two skills. One which was the name of the word, the intended word, and one which was the predictable error. So in this example, say skill A would be wet and skill B would be what. We then sent the testing set through to Alexa as a skill command and observed how many times skill B was triggered instead of skill A. I want to mention, a brief kind of like ethical note. We validated this attack strictly in a developer environment. There were no real skills that were targeted in our validation experiments or tested in production. And we understand, this is kind of a fundamental limitation of the claims that we can make both in the paper and here. But it's what we thought was kind of the right thing to do. So what did we find? Well, in total, of the 27 predictable errors that kind of were earthed out from the training set, we were able to successfully squat 25 of those at least once. Of course, not every squat worked every single time. The full distribution is in the paper, as well as some explanations for why some things that we expected to work actually, didn't really work out so well. So if you've stopped paying attention at this point, I get it. It's like, oh, this guy is talking about some cute attack. There's homophones. Alexa makes mistakes. Who cares? I don't even like cats. Why does this matter, right? Okay, I get it. But this matters because cat facts, turns out, is not the only thing that you can squat based on the kinds of errors that Alexa makes. As I said before, your voice is going to be used to do everything, or at least this is Amazon's future of the world. You can use your voice to buy stuff, and you can use your voice to do banking, maybe through the American Express skill. So let me show you an example of what squatting the American Express skill might look like. So I might owe my advisor $100. I don't know why. But let's say I ask Alexa, oh, Alexa, ask Amex to pay Bailey $100. And Alexa, okay, there's one skill that sounds like Amex, sounds great. But the thing is, Alexa doesn't have the credentials to actually make this request on my behalf. So what she'll do is she'll send me back a thing that says, oh, I don't have the credentials for that. You need to log in. I've sent a card to your phone. What does this card look like? It looks like a login page. Okay, great. I log in. Everything works fine. Now, let's say that the attacker, based on a methodology that's very similar to ours, knows that Alexa prefers character representations of words rather than the full representation of the word. So they've registered a skill that's called am space X. Alexa, instead of choosing the Amex skill or the official Amex skill, chooses am space X. And the attacker has studied the interaction model. They know exactly how this works. They say, oh, you need to log in. I've sent a card to your phone, and you're phished, right? So, it's cute. Yeah, skill squatting is this cute example, but you can see even in this one demo how this can be used as a gateway to launch more complicated and phishing attacks in kind of this new domain. So a link to the full video of this demo you can find in the paper. Working like in the actual environment. So I want to take kind of change gears a little bit and talk about another angle of the skill squatting attack. And this is based on a growing observation that Alexa and other speech recognition systems don't really work as well if you have an accent. And in some sense, this kind of makes sense, right? Like it's hard enough to do speech recognition. Now, given the fact that everyone speaks a little bit differently, that's even harder to do correctly. But this observation got us thinking about another research question. Do different regions exhibit unique, predictable interpretation errors? Right? So based on the way that you speak, are there things that Alexa thinks are different, but just for people that sound like you? And so what I'm showing you here is a six-way intersection, or you can think of this like a six-way Venn diagram to visualize where different predictable errors come from per region. I'm going to break this down. So if you look at this part of the graph, what this shows is the distribution of predictable errors by region. So speakers from the southern region of the United States had 2 predictable errors. Speakers from the Midland region had 8 different kinds of predictable errors. If you look at this part of the graph, this kind of, you start to see, okay, how are these distributed across the different regions, right? So if there's a dot connecting some group of regions, what that means is that that group of regions all exhibited the same error. So for example, you've got these 3 particular words. They were shared across speakers from the North and the Mid-Atlantic region. But what's most interesting is this part of the graph, which shows that for 5 out of the 6 regions, there's actually predictable errors that are unique to speakers from that region. And from that motivation and kind of following on from that, we introduced this variant of the attack in the paper called a spear skill squatting attack. Say that 5 times fast. An attacker, the core idea here is that an attacker, similarly to the skill squatting attack, can launch a skill squatting attack, except now they can target you based on how you speak. And in order to kind of validate that, what we did is we took the 11 predictable errors that were specific to a specific region, and we applied the kind of identical technique where we split up the speakers into a training set and a testing set. We identified what was predictable based on specific regions, and then we wanted to see if the rate at which we were able to successfully squat speakers from a particular region was higher than the rate of everybody else. And so that's kind of what this column represents. Really the question here is, okay, was there a significant difference between the attack success rates in both of those scenarios? If yes, then we consider, okay, that's a successful attack based on, targeting specific groups of people based on how they speak. So in total, we were able to successfully squat, 8 out of the 11 spear squattable pairs, with, of course, varying levels of success in each case. I want to note, this, of course, we have limited data and limited insight here. There's only 10 speakers from each particular region, but this result does suggest that, this kind of targeted attack may be feasible with more data and in other ways. So I want to talk briefly about some of the limitations of the work. I mean, of course, I think top of mind to everybody and top of mind to us as well. Okay, scale and representativeness of this data set, right? You've got 60 speakers, you're trying to make some claims about speakers in the United States. You know, it is hard kind of to make these broad general claims, but we did find that the signals were strong enough to indicate statistically significant trends. You know, unfortunately, there aren't great public data sets that kind of investigate these kinds of problems. You know, the fundamental requirement for, say, this particular study is that we needed to get a bunch of people all from different places that all said the same set of words. And it turns out that that really doesn't exist. So I think that a cool area of future work, maybe even curating a data set, like I think it's a great area of future work. And of course, I touched on this before, but demonstrating this works in a development environment versus a real production environment stretches just a little bit. But let's take a step back, pop up the stack, and what are some of the meta points that we learned? So, well, the first thing is, okay, it's shiny, it's new, it's cool, it's IoT, it's hot, but it's got the same problems as before. And in a sense, skill squatting is kind of like typo squatting, except in the land of IoT. The fundamental difference being that typo squatting, the attacker is hoping that the user makes a mistake. You put 3 O's in Google instead of 2 O's. But in skill squatting, the attacker leverages a kind of a fundamental property of the speech recognition engine. So it's like, in typo squatting, it's like typo squatting, except, as a user, you can't see what you type, and everything goes through autocorrect before it's shipped off to make a decision on your behalf. And this kind of ties into my next point, and something that I guess is echoed from the keynote as well. The opaque machine learning for decision making is still really, really new. And interface quirks, whether they be in gestures or in voice or your facial recognition, can and will be abused by adversaries to kind of cause harm. Okay, moving forward. We alerted Amazon about this stuff back in February when we submitted the paper. They confirmed it, and they're working on it. And so we have good news from them that they're working on fixing the problem. I think one cool area of future work is kind of measuring the widespread harms of skill squatting, but in general, this idea that if we're going to use voice for everything, where is that going to start to break down? We saw a phishing example. Is this going to happen in online shopping or some other kind of context? And finally, I think investigating this notion of IoT trust. On the web, we as users, and we've conditioned people to say, oh, there's a browser warning. Maybe I shouldn't go on that site. It's got a virus. Or, oh, it's got a green lock icon. I feel like I can trust that a little bit more. But we've not built anything yet as to what kinds of applications are trustworthy in this new environment. And so I think investigating that a little bit more deeply could be beneficial for both IoT and for the security community at large. So I think that is my time. And at this point, I'm happy to take any questions. Thanks.
Hi, this is Alfred Chen from UC Irvine. So I'm thinking about this, and then it seems that in our real life we recognize this. Basically, we tell the ambiguity from the context, right? From the conversation context. So, for example, in the Google I/O, it's already showing that the Google Assistant can tell some of the context by the history of the conversation. So I'm just thinking that since the voice recognition technology are evolving to involve this context to tell this ambiguity, so do you think this is more of like a short-term problem, or there's more fundamental things behind it?
So I think that there's two bits, right? So yes, context is very important for speech recognition. And in this case, we're not really looking at context, but also in this workflow, there's really not a lot of context for you to go off. It's like, I need a skill. The skill is called A. And how do you know what A is if it sounds like something else? I think it's kind of an outstanding question. What to do about this in the long term, I think an immediate fix would be Amazon, when they're doing in skill registration, say, okay, does this have some kind of phonetic structure that's similar to another skill? Can this be invoked in the same way? Is there confusion? If so, you can't use it, right? So some other platforms have started to do this as well.
Yeah,
but
I guess one thing is that the current this voice assistant are not very natural. You just give it like a command, but in the future, I guess, if it will merge into our daily conversation, for example, you will know that I'm going to do a payment, not doing AMX, right? It's AMX. I think
Yeah.
that.
I think that the idea here is like if your first interaction with this skill is compromised, and that you need there's no context, right? Then it doesn't matter. The attacker knows, the attacker is building a skill for the express purpose of squatting that banking app. So it's going to sound like a banking app, it's going to feel like a banking app until you sign in with your credentials and they say, okay, thanks, I got your credentials, haha, bye. So yeah, I think that it's a good point. But still, the threat vector of like as soon as you start, it's really the first interaction with the skill, which is the problem.
Yeah, thanks.
Yeah, so I think she actually had a good point. We're actually using the context information of the voice commands to defend against this kind of attacks. We also like almost at the same time we independently found the similar problem, and also we have the defense paper out. So yeah, thank you.
Hi, awesome talk. I have a quick question. So you mentioned that the vulnerability essentially stems from the fact that the speech recognition is not able to differentiate between a word SAIL or SAIL. Yeah. Have you also looked at Google Home? I know like Google Home has a different type of skills, but not exactly. Yeah. Because when you do transcription at least with Google API, it gives you at least 5 to 6 options or even more, right. And it provides a ranking. And same is with like IBM Watson transcriptions. So does Amazon Alexa also has, because they don't have a speech to text service per se, right? But did you see, or when you talk to Amazon, do they have a ranking procedure to rank basically like all these things? Because I've seen from Google experience, they give a very good overall accuracy for the exact word, and they would have all the alternate options with like very low score. Yeah, that's a good question. So so at the time, and even now, I think there's no like Alexa API. They have like a transcription API, but the way that we did this was we actually used Alexa we built a skill around Alexa to kind of transcribe these things for us. So there was one choice that she made, and we kind of used that as the intuition behind that is like, okay, well, if that's what the system is doing now, then that's probably what the system is doing in the wild. So there's no similar like analog where it's like, here's 5 options and here's what you can choose. At the end of the day, though, they're making a choice, and so I wonder. We haven't tried this with like the Google Home API or something like that, but I wonder like what that would look like. So I think it's a good point, but I'm not sure. Just a quick question. So would the easiest fix be to not allow users to enable skills by voice activation, instead like go to the phone app and then enable it? I know it compromises a whole lot of usability. Yeah, I don't think that that's really, I mean, I think that the right answer right now to prevent this specific kind of abuse is at skill registration time, which I think all of these platforms have some kind of like review process, but as in our experience, it's not, like it's not designed to do this kind of stuff. It's just designed to say, does your skill, actually work? They should basically say, okay, here are the ways that, because you have to enumerate the ways you can invoke a skill. So is that invocation, is that easily confused with something else that we already have registered? So kind of like how like with usernames, you can't register a username that's exactly the same as somebody else's on the same service. Something similar to that, I think is the right answer. Would this prevent the first attack vector that you mentioned? Like when I interact with a skill for the first time, I should not be able to enable a skill through voice. I'm saying that they can't even register the skill. So the adversary can't even register am_X because it sounds a lot like Amex when you say it out loud. Oh, I see. Okay. Yeah. All right. Thank you. Yep. Thanks.
Real quick, Simpson Garfinkel. You described. This is bad. You described skills as like apps, but on my cell phone, it doesn't load every single app from the App Store when I turn on my cell phone. And it sounds like every skill is active. And that doesn't sound scalable. And because there'll be more and more, and sometimes the same words work in different contexts, different ways. Right. And so I was wondering, when you read the Amazon security model, what it used to explain this. And related is, why do you not get the same results with the same speaker and the same word every time, but you get different results?
Yeah, that's a good question. So your first question, which is, it doesn't sound scalable, like what is the kind of intuition behind it? I can share with you kind of like the way that they describe it. I mean, really it's just, we want people to be able to use skills, so we're going to make them enable by default. I don't know how it particularly works on the back end in terms of like what they're actually making, the actual decision making. Your second point, which was, sorry, what was your second question?
you're getting different results for the same inputs.
Yeah, that's super weird. So like we observed this, and we have this in the paper too, where we like sent the same audio sample multiple times. We get different results every single time. We think that this has something to do with like load balancing or maybe A/B testing. So like, you might actually be getting a different trained version of the model every time because you say something, Alexa says, okay, I need to distribute this to some server. Okay, that server has a copy of the model. Maybe it's like 5 days old, but who cares? Just send it to them because it's probably right enough. This is like the best guess that I have, but I don't work at Amazon, so I don't know. But thank you.
Okay, let's thank Deepak again.